And we are back. Thanks for tuning in. That's fully game here at IoT Stars, Embedded World 2026 in Nuremberg. Here at Fabrizio, we're going to talk about IoT, right? It's the IoT show. We're going to talk about AI at the edge and what's going on at STMicro. How are you?
Yeah,
Thanks for
good.
coming.
You?
Good night.
Hello?
We met like 10 years ago,
Yes.
something like that.
Yes,
I was
at the
with
beginning
Microsoft.
of IoT.
At the beginning of IoT. Yeah, 10 years. Yes.
Yes.
We're talking already Azure to cloud,
Yeah.
connectivity,
Yeah.
platform for devices. So, well, 10 years. What has happened since then? Where are things?
Yeah, a lot.
Yeah.
I think. First of all, AI came into the picture,
Yes.
and
Big time.
as this is the topic of today,
Yes.
Edge AI, I think, is one of the reasons why you will need more IoT.
Okay.
Because if you want to do AI at the edge, for sure you need to connect.
Yes.
Because when you want to do inference and you want to do what happens, then you have to go to the cloud to connect the data, to take some action. Typically, systems are distributed. It's difficult to have a device that is just itself. So this adds up to the fun.
Yeah, you're not the first one. And I know that's the theme of IoT Star, which is basically IoT is powering AI at the edge. I like it. I think it makes sense. And we hear a lot talking about physical AI,
Yeah.
which is about
Yeah.
the AI that senses the environment, interacts with it. And IoT is the tool for
Yes.
AI to touch the
Yes.
world, right?
Yes.
Awesome. Anything new at STMicro when it comes to IoT and
Yeah.
Edge AI? Actually?
Yeah, no, we do a lot. We do, as you know, our portfolio includes sensor, microcontrollers,
Yes.
and we've been busy, and connectivity, of course, we've been busy to put AI at the edge, at the deepest edge.
Okay.
So today we will show a tool called ST IoT Graph
Okay.
that is an end-to-end solution to develop AI inside the sensor. We have inside the MEMS a tiny AI that we can program so that the sensor itself gives you already the inference. You don't have to stream all the data.
Nice, nice. So you already are able to have a sensor that intelligently filter out
Yes.
the nominal, uninteresting information
Yes.
and send something that's already compiled as an information, as an insight.
Yes.
It's pretty powerful. You need to balance power consumption as well.
Yes. Yes.
Memory availability.
Yeah.
With the cost of memory these days not
Yeah.
easy.
Yeah.
How do you propose customers approach this balance? How do they know if it's better to run AI at the edge or to have a hybrid model where eventually you also have cloud in place?
Yeah. Typically, the deepest you go, the more energy efficient you are.
Okay.
A MEMS sensor consumes much less than the microcontrollers, that consumes much less than NPU, that consumes much less than the cloud.
Yeah.
So the deepest you can push the inference, the better it is.
Okay.
Also because you will stream less data upstream. So if, for example, you don't have intelligence in the sensor, you have to stream all the data to the microcontroller.
Yes.
The microcontroller is much more power consuming.
Yes.
And you have to move data on the board.
Yes.
So that's one example.
Yes, yes. And then if you have to send to the cloud, you have to send data
Yes.
over the air on radio, which actually consumes a
Yes.
lot as well.
Yes. And this is one of the reasons why everybody, even cloud providers, are interested not to waste so much effort in sending all the raw data.
Yeah, yeah. That's interesting. It's kind of backwards. People are saying IoT data feeds AI, but actually we're realizing we need to bring AI to the data as well. It's not just about sending more data to the cloud to feed big models. It's also about bringing it down there. Then we're realizing that, guess what? These big models can be adapted to run on tinier devices.
Yeah.
So we can have noise cancellation. We can have translators.
Yeah.
We can have a bunch of things. Are you seeing also an uptake of agentic AI at the edge?
Yes.
In what form?
So here, I think now we are used to the big LLMs.
Yes.
There is a trend, a research trend, that is trying to fit smaller LLMs closer to the edge. And again, it's for the same reason.
Yes.
So this is typically what can happen. And I think even agents that will orchestrate context will be coming. So
Yes.
more, even in software development, you will teach an agent to write the application for you.
Yeah, there's a developer tool aspect of things. There's the agent to help you configure a device and so on. The agentic model is going to be interesting for automation on the device itself as well, right?
Yes.
Having a logic that lends to an action, that lends to a reflection on an observation, reflection. This is agentic loop that can happen. It's perfectly fitted for embedded in IoT devices.
Yes, and you were mentioning before physical AI, humanoid robotics. This will be a typical case where you will have maybe a central processor in the robot. There will be a big processor with big Gen AI engine there, talking with the hands, the legs, where there will be more tiny devices, and it's the same architecture.
So that means also more chips, more distribution, tinier intelligence everywhere. Not one big brain, but multiple tiny brains here and there, right? So more work for us.
Yeah.
Awesome. So last question for you. What are you excited about for 2026?
So I think those two things we mentioned. First of all, the arrival of Agentic, so that we'll be able to program the agents that do more job for us. So we'll be much more efficient. So personally, I believe this will help us, not create a threat for us.
Okay.
And the second thing is the physical AI. This will be the next big transformation.
Yes.
I'm really looking forward to work on that.
Okay, me too. So see you next year, and we'll talk about that and see where things are at.
Yes.
So maybe us, and hopefully not robots instead of.
I will send my agent next year.
Stay tuned. We have more people for the show coming up in a second.